All right, so we are first going to set up a matrix based on the system, and the matrix is going to be based off of the coefficients. So we have a 1x, so I'd put a 1, and a 1y. Where your equal sign is goes like a kind of a straight line, and then the 13 would be on the other side. And then the second equation would be 1, -1, and 5. So that means 1x plus 1y equals 13, 1x minus 1y equals 5. So our goal is to ideally turn this left side into the identity matrix using these same kind of things that we did yesterday. So, and again, going through the process in the same way. So we would make this a 1, already done. How would you make this one a 0? What would be the algorithm? What are we going to do to row 2? So really, all we have to look at are these two numbers. What'd you say, Alyssa? Right, you're going to take that number, and you're going to subtract that one. So it's row 2 minus row 1. And that's going to replace row 2. So your top row is not moving. 1 minus 1, 0. -1 minus 1, -2. 5 minus 13, -8.
Why can't you just do row 2 minus 1? What is it? Yeah. Row 2 minus row 1.
You can't just subtract a convenient number. You can multiply and divide by a convenient multiple, but you can't just subtract 5. You have to add or subtract another row, or add or subtract another row times whatever multiple is convenient for you. It's just the rule. It won't work. It won't turn out. So now we're here. And so our next step is to get what number changed here? Not next. You get a 1 first, and then you zero out that column. And then you get the 1 in the appropriate spot on the next one, and then zero out the rest. So you kind of work diagonally to get your identity matrix. We want to make this a 1. Yes? How would we do that? Or divide row 2 by -2. Getting a 1 is easier because you can just multiply by or divide by. So I'm going to take row 2 and divide by -2 to replace row 2. And then my last step is to zero out the rest of that column, which is this spot right here. So just look at that little column. How do I get that top number to be a 0 using the only other row we have as an option?
Row 1 minus row 2.
Right. We're going to take row 1, and we're going to subtract that row 2 number to replace row 1, which, because we've kind of perfected that first column, it's not going to mess anything up, because this 1 minus this 0 is still going to be the 1 that we want there. 1 minus 1 here is going to give us the 0 that we want. 13 minus 4 is 9. And our second row stays the same. So x equals 9 and y equals 4. Right? 1x plus 0y technically equals 9. So that's x equals 9 and y equals 4. Now I will tell you this. You can, and I'll say this, you can get 1s all the way across and just make sure everything below your diagonal is a 0, and then start with your bottom row and say, okay, y equals 4, And then up here, that would be 1x plus 1y equals 13. But now that you know y equals 4, you could just write x plus 4 equals 13, and you'd still get your x equals 9. Does that make sense? So some methods of this will say you don't really need to get the full-fledged identity matrix. You just need to get ones all along your diagonal and make sure underneath that, at the very least, you zero things out. Does that make sense? Okay? Number 2, we're going to we don't have any ones in place already, so it's just a little bit stepped up. So which of these numbers on the left should we attack first? The top left 2, right? Needs to be a 1. So we divide it all by 2. Row 1 divided by 2 is going to be your new row 1. Did your pencil just break, Brock? You fired a projectile at me.
Yeah.
It's right there.
Right.
Yeah.
Did you ever do like row 2 minus row 1 equals row 1? Or did I have to do row 1 first?
So say that again. Are you trying to tell me a different option for that?
Yeah, like could I do row 2 minus row 1 goes into row 1, so it'd be like 3
row
minus
2. Sure.
Like you could start with a different row and make it.
Yeah. As long as you're trying to get this a 1 as your first step, however you do it is fine, as long as if you're going to add and subtract rows as opposed to using a multiplier, you just have to make sure you're not doing like a row 2 minus 5, because you can't just subtract your convenient number. But I will blanketly say I think you wouldn't have to be as creative if just to always get a 1, you multiplied or divided by whatever number. Just to start. Just the easiest way to get a 1. And then to get zeros, if you just took that row and subtracted that multiple times the row 1, or the whatever row had the 1 in it already. All right, so now we need this to become a 0. Come on, Mike. I need this 3 to become a 0, and I can only use row 1. Perfect. R2 minus 3 times row 1 is going to replace row 2. Try to fill in your new row 2 on your own and look up to mine only when you're ready to check yours, because it doesn't really do you any good to just copy down what I have. I know a couple of you have come up to me and said that you just started using a calculator, and I don't really blame you for the fraction stuff. Rather than doing it in your head, just typing in 3 minus 3 times 1, get your answer. 2 minus 3 times negative 1/2, let your calculator do the work. Switch it to a fraction using the calculator at the end. And then 4 minus 3 times 5/2, and just let your calculator do the work. And then 7/2. Because this can be our last step if we just make our diagonals 1s and our zeros below that, which we already have. What'd you say? 2 minus a 3 times the negative 1/2. So that's going to be 2 plus, right? So if you use the calculator, you'll just have to think a little bit less, which is good for something like this, where your head, you want to like do that. All right, so how are we going to get rid of that 7/2? Turn it into a 1. Anytime you turn something into a 1, you either want to multiply by something or divide by something to get that to happen. What would you have to multiply 7/2 by to get it to be 1? 2/7. So that's your multiplicative inverse property. What would you have to divide 7/2 by if you wanted to do it that way? 7/2 divided by what would give you 1? Right. Anything divided by itself will give you 1. I probably would steer clear of dividing by 7/2 unless you're absolutely positive on your calculator. For example, when you get to this one, negative 7/2 divided by 7/2 is not going to give me the right answer. Because you're dealing with fractions, if you want to do it, you have to keep each fraction in parentheses. Negative 7/2 divided by 7/2. Now you'd get the right answer. Negative 1. So I'm going to take row 2 and multiply by 2/7 just because somebody told me never to divide by a fraction, to always multiply by the reciprocal, so I've just done it that way. And that's going to replace your row 2. So row 1 is unchanged. Row 2 is 0, 1, negative 1. Now, what does y equal? 0x plus 1y equals negative 1. So y equals negative 1. Does everyone see that? And then if we're not zeroing out everything else, we're just going to have to go back and realize that 1x minus a half of negative 1, right? That's your y coefficient. So 1x minus a half of y equals 5/2. I just replaced my y with negative 1 now that I know it's that. So that's x plus a half equals 5/2. Subtract a half on both sides, and x equals 4/2, or 2. So 2, negative 1 is your solution.
But why did you do x minus 1/2 times negative 1?
So if I zero everything out, my answers are just there.
Yeah.
But if I kind of go the lazy man's way and I just get the diagonal across, I would start with my bottom row. I now know that at least y equals negative 1. And so this is 1x minus a half y equals 5/2. This first column is always my x coordinate. That's my y coordinate. So I just had negative 1/2 of y, and I now know that y is negative 1. So you kind of like plug back in what you know to the previous column each time.
Okay.
Any other questions?
Oh, a little public service announcement. The class is wet, but it's not paid. Word.
Thanks. All right.
I would have thought it was Peter.
This next one is our first 3 variable one. Where you're missing a term, you got to fill in a 0. So when we set up our matrix, 1x, 1y, 0 z's equals 3. Negative 1x, 3y, 4z equals negative 3. And then 0x's, 4y's, and 3z's equals 2. So, on the left side, which number do we have to tackle first? Val, the negative 1. Okay, we have to zero that out. So, we're going to take row 2, Val, and do what to get that to be a 0? Well, we have to add or subtract another row or a multiple of another row. Perfect. You just add row 1. It doesn't really need a multiple here. And that's going to replace row 2. So, negative 1 plus 1 gives us the 0 that we wanted. 3 plus 1 is going to turn that into a 4. 4 plus 0 is a 4. Negative 3 plus 3 is a 0. And I'm not touching row 3. What number pretty much do I have to tackle next? Sarah, do you know? The 0 at the top in the second column? Okay. Eventually, yes. But you always want to get your 1 in place in each column first. So I got my 1 in place and I zeroed out everything else. I want to get my 1 in place here. So which one of these numbers should be the 1? The first 4, exactly. So that's really what I want to tackle next. Then I'll worry about the zeros. Are you good with that? Okay. So how, Sarah, would I get that to be a 1? When you're trying to get a 1, you guys, you don't use the other rows at all. What do I multiply it by, or what do I divide that by to get it to be a 1? You just use a straight multiplication or a straight division when you're trying to get a 1. So divide row 2 by 4. I'm going to write that out when we're done with this one, just so you have it like in writing. I have to go down here. So not touching row 1 or row 3. And everything in row 2 divides by 4 nicely. So I actually escaped without any fractions. Now, if you're going for the full identity matrix on the left-hand side, both of these would have to be zeros. But if I put my pencil across the diagonal, the only ones we really have to get zeros, if you want to do less work, is anything underneath that diagonal, so the 4. So let's just not even worry about this one. Let it be whatever it's going to be. But this 4, I somehow have to obviously subtract 4 from it, right? To get it to be a 0. This one's actually interesting because both of the other rows have 1s right now. Which one do we want to use? And it does matter. Nope. If I take this and I subtract 4 times row 1, I'm going to screw up this number. So you want to use the identity one, right? This one is a coincidental one. Does that make sense? This is coincidental. Don't use that one. Use the one that we intentionally made a 1 because it's the one that we know also has a 0 prior to it. Okay? And we'll let that's kind of a rare case where you actually had 2 choices. But use the identity one. So I'm going to take row 3 and subtract 4 times row 2 to replace row 3. So 0 minus 4 times 0 is still 0. 4 minus 4 times 1 is 0. 3 minus 4 times 1 is negative 1. 2 minus 4 times 0 is still 2. And the only thing we need to do now is finish our diagonal 1s. So how do we get this here, Faith, to be a 1? Divide by negative 1. Good. Row 3 divided by negative 1. Yeah, Caroline.
Did you also multiply by
Yeah. No, same thing. You can multiply or divide by whatever number works. Anytime you divide by something, if you multiply by the multiplicative inverse, it's the same thing. So even up here, when we divided by 4, if you had multiplied by 1/4, same thing. And so what variable do we know first? Laura? Z is -2. So Z is -2. That's your last row. Then you would just domino effect backwards. We've got 0 x's, if you want to write out that you can, plus 1 y, plus 1 z, but z is -2, should equal 0. And if you solve that, just by, that's technically just y minus 2, right? By just adding 2 to both sides, you'll get y equals 2. And then domino effect back to the top one, so we can find x. We'd have 1x plus 1y, but y is now 2, plus 0z is supposed to equal 3. So your 0z is a wash. That's really just x plus 2. So I'll subtract 2 from both sides, and x equals 1. So your answer is 1, 2, -2. X, Y, Z. Okay?
Wait, so what column do you do that?
X, Y, Z. So however many variables, if you had A, B, C, D, the bottom row, if you get 1s diagonally and 0s all prior, the bottom row will be always your last variable, your D. Then you go back up and you find your C, because everything prior is zeroed out. So,
Yeah, 1 minute.
It would be X, Y, Z, not
X plus.
no, when you set it up, let's go back. It's 1x plus 1y plus 0z equals 3. So these are your coefficients of your x's, coefficients of your y's, coefficients of your z's. But when you are getting to your, if you're backtracking row-wise, this will give you your last variable first. Then you domino effect backwards, because you'll know that number now to find this one. And then you'll kind of go backwards and get your variables from there.
So you're finding your variables is X, Y, Z.
Yes. Yeah. Okay? So, your homework. The first part of your homework is pretty simple, just to turn the system into a matrix. That's all you have to do for the first section. Then on the next section, they're already set up for you, and they've actually already told you what row operation to do. And then only the 2 at the end are doing completely on your own using a matrix. Capiche? Okay. Do the odds, except for I want you to do both of the last 2. All odds plus 20.